Today we're talking about faceted navigation. We'll talk about what it is. I'm going to do a very short demo. Snehal is going to walk you through a technical discussion and a deep dive of what we've done, and we'll have a little bit of time for questions at the end. So what is faceted navigation? You probably all have used Amazon before. I know I have. I use it a lot. So one thing that happens if you go to Amazon to search for something, in this case, this screenshot I've searched for laptops. What happens is you're going to get back a list of results. And then on the left-hand side of Amazon, you're going to see all these different categories of things. So in this case, you'll see categories like featured brands, price. There's some that are like specific more to how Amazon works as far as like the department and stuff like that. So there's these different categories, and under these categories, there's different values. And the values are things that relate to the products you've searched for. So in this case, so I'm searching for laptops. The values for brands are going to be brands of laptops. If you're in this, also the price of a laptop is coming up in some sort of bucket. And so what the facets are is a combination of these categories and values that relate to the thing you're searching for. And then what you do is you select values. In this case, I've selected Dell. Even though I'm a Mac guy, I selected Dell because Mac didn't come up when I searched for laptops. I picked Dell, and then I also picked 1,000 and above. So these two facets or these two facet values I selected as a user. When I did that, Amazon went ahead and filtered the list down so you can see that the list here is only showing me Dell laptops that are priced greater than 1,000. And so it filters my results. So this is just a way for a user to kind of quickly like hone in on specific things they care about. What we've done the same thing using a Neo4j data set. We've used the movies data set, not the little baby movie set in the training, but there's a larger movie set with like around 10,000 movies, 4,000 directors that's available as one of the sample data sets we have up on our website. And there's a link later on for that. So we have facets that are applicable to our data set. In this case, since we're dealing with movies, we have genres, ratings, revenues, those sorts of things. The moment genres is collapsed, so we'll see the values of those in the demo. I got ratings expanded, and the ratings, the values that we pick can either come from the database itself, or you can define them like what you think a user would want to search on. So in this case, I thought a user might want to search on like good movies or excellent, which isn't an actual value in the database, but it's a bucket that I've defined from a user interface perspective that we can use to help narrow the search down. And we'll explain how that works. One thing that we've done, in addition, so it's a little bit different than Amazon example, is we have value counts. So I don't know if anyone's familiar with, back in the day, there was like a product called Endeca. I think Oracle bought them. There's also Solar, like an open source product. And these products provide this style of search, this faceted navigation, when they bring back the facets that relate to the results, they actually bring back these counts as well. So Amazon doesn't bring back the counts, but in our case, we wanted to be like more closely aligned with what you might find from like a commercial or open source product. So we brought back value counts. It provides a little bit of like some analytics on the set that you're narrowing, you're going to narrow down. One other note here is we are currently limiting the results to 250, and there's a technical reason for that just because of this demo. But if you do it on your own, we'll talk about the trade-offs of what that limit is, and it can be much higher than 250. We just picked 250 for the demo, and we'll get into that later. So what we've done is we have an open source project, and the open source project, we'll give you a link at the end. We built it using Next.js. Next.js, if you're not familiar with it, is a popular JavaScript or popular framework to build web apps. And we went ahead and used Next.js is really nice because you can define both like the UI rendering code and like the API access all on the same project. And then Next.js like figures out like where to run what. I think originally we said we were going to talk about GraphQL in the description, but we do have a project internally that uses a GraphQL like API, but it was a little bit of overkill for this. So just for this, we're using the Next.js API only. It's like a REST call. But anyway, so the Next.js UI, it has the rendering code to render results. It provides the clickability. So if someone clicks on something, it captures the state, and then all those things get put together. There's a Cypher call that's made through the API to a Neo4j Aura DB. The Aura DB has our sample movie data set, and then it processes the Cypher query. It returns results in JSON, and then on back to the UI and gets rendered. So Sneha will go through all the details of that when she gets to it. So now let's look at a demo. Let me do this. I've got this. This is our sample demo. When you get, if you're curious, you can download the GitHub project and run this on your own. When it first comes up, as I mentioned before, we have a limit of 250. And so that's what's showing up here on the results side. On this side, we've got our facets. And I'm going to go ahead and click 2010 here. When I do that, the results change. So now I'm looking for movies now that have been released in the decade 2010. I'm going to go ahead and click a few other filters. Now I'm going to click adventure, and when I get down to adventure, so now I'm below this 250 threshold. So now I've got 189 results, and what that means is if I click on other things here, these analytical facet counts are going to be accurate based on the entire data set. So one thing you can do is I'm going to look at movies greater than 1 billion, and these are probably things that you may have seen. Some of the Avengers movies, The Dark Knight, Finding Dory, Frozen. The way the facets work is, though, what happens is it actually builds a query in the back end. And if you were to look at the facets that I've selected here, so we have movie years 2010. We have genres, which is adventure, and we've got this down here, which is greater than 1 billion. These are all ANDed together. So it's like, look for movies, revenues greater than 1 billion, that are genre, adventure, etc. If I want to like say add this as a criteria, let me show me movies between 500 million and 1 billion, and then greater than 1 billion. So now this is an OR condition. So we have ORs that happen within a particular like category, and then you have ANDs across categories. And this is how you get and filter your data set. So Sneha will go through all this in greater detail. Let me go back to the slides. And two types of facets that we deal with. One is what I'm calling a property value facet. And in our example, we have genre as a node or a node type, and it's got a property called name. Some example values are like action, comedy, sci-fi. And what you do is when you want to draw the facets initially, you want to get the distinct set of values from that string property. So in this case, there's like, say, 40 genres or something like that. And each one of those genres is shown back in the UI. And then when a user goes and clicks on the genre, then that becomes like search criteria. And then you do an exact match on like a genre associated with the movie. And that exact match is like what the Cypher statement is doing to like narrow down your movie results. We also have predefined range buckets. And this is where you have to put like your UI hat on and think about your users and kind of think about what they'd want to search on. So in this case, we said, well, movie revenue might be something I want to search on. Let's define these buckets. And we define these buckets. They're actually hard-coded in the UI, and they're hard-coded in the Cypher statement together. So they have to be correlated with one another. And so you use buckets in situations where you have like an integer value or some sort of numeric value, and you don't want to show those numeric values because there's like, you can't really say like search on 6.2 or 7.3 or something like that. So we put these buckets up, and then when the user selects it, there's like a low and a high range. That low high range gets passed back to the back end and becomes part of the filter criteria, and then therefore the results are appropriately filtered that way. The high level view of how this works is there is in the UI there's this JavaScript object that's used to capture the user's selection. So it's a search criteria object. The user says, let me look at movies with genre adventure. That string value gets added to the object. And then if they say, like, let me look at movies over 1 billion, there's a low high range that gets added additionally to the JavaScript object. And then we have what's called a two-phase dynamic Cypher statement. And if you're new to Cypher, this is going to blow your mind. If you are an advanced Cypher user, it's probably still pretty advanced, but you probably understand it. What it does is it takes the search criteria as a parameter, and then it goes through and uses Cypher to generate Cypher. So it basically translates the search criteria JavaScript object into a Cypher statement. And then within the same Cypher statement, it uses apoc.cypher.run, executes the dynamic Cypher statement, gets results back, and it does the facet count computation. So Snehal will go over how that works. And then that generates JSON back to the UI. And in the UI in the Cypher, they know they have sort of like this key mapping. So every value that gets rendered in the UI has like a unique key for the category plus value. And the Cypher statement knows how to construct that and the counts. And so that's how it gets matched up. And with that, let me, I'm going to stop sharing. Or that was, yeah, let me see if I can stop sharing my screen and let Snehal take over. There we go. Over to you, Snehal.
Thank you. Thank you, Eric. So I'm just gonna share my screen. So I'm here to give you a technical deep dive into all the stuff that Eric mentioned on how the search criteria is being set and how the dynamic cipher works. But before that, I just want to give you a quick overview of the graph data model that sits in the backend. So we have the movies node, which is in the center, and we have movies connected to genre. We also have the person node, which can be an actor or a director, and that's connected to the movies with these two relationships, acted in and directed in. And then we have user nodes that are connected to movies who have rated the movie. And these are some of the properties that we are using in order to apply the filtering or apply search criteria. So I'm gonna escape this and switch to my UI screen. So this is the user interface. On the left, we have some of the facets that Eric mentioned. So what I'm going to do is click on inspect, and we can look at the network traffic every time I make a selection here. So let's select 2020, since that'll bring up all the recent movies. So we have 2020 selected, and in here you can see a REST API call that's getting made, and this is the request payload. So I'm gonna increase the size over here just a little bit. So in the request payload, you can see that there's a search query that's getting invoked by the API call. And then there is this object called options and another object called parameter. And these parameters are getting passed to this search query. So since I selected the year range to be 2010, you can see that inside of my search criteria, I have a year range where the low is 2010 and the high is 2020. And that's the predefined bucket range that we've specified in the backend. So what I'm going to do now is just collapse this and add another filter condition. So I'm going to select adventure. And you can see now we have another API request that's been made. So basically what happens is that every time you're going to select something on the facet search, there's a new query that's going to get kicked off, and it's going to update the search criteria. So earlier we just had the year range, and now we have another filter on the genre, and we've selected the value to be adventure. So it's going to be a multi-value field in case I select more genres here. So I'm going to collapse this, add another filter condition. So let me just reduce this, and I'll apply another filter here, whether IMDb rating is good. So just, and in here we can see another network request being sent, and we have the three search criterias that we applied on the user interface. And this is the response that I'm getting back from the API. And basically, this response is getting passed and then displayed on the user interface. So what I'm going to do now is just go through this Cypher query, which is doing all the work in the backend. So I have my database over here, and I had added that query as a favorite. So I'm going to run this, and it's going to ask me for a search criteria because I've not said that. So what I'm going to do is pick up, copy the search criteria, and paste it over here. Just going to make sure I don't have duplicate values. Basically, I'm just setting a parameter search criteria, and these are all the filters that I applied on the user interface. So I'm going to run this, and this is my phase one query. So I'm just going to run that. And in the results, you can see that I am getting the Cypher query based on the search criteria that I passed. So I had a filter on the genre. So I have a match statement here for the genre. Then I had some more filters on the movie node. So we have another match statement on the movies node. And then you can see that it's been instantiated by the same variable movie, so that the results are consistent. And then we have like the three where conditions. So the first where condition is for the genre. The second one is and condition for the year range. And then the third one is for the IMDb range. And if I have to give you like a quick walkthrough of this phase one Cypher query, so what this does is that it's basically picking up the search criteria that was getting set on the user interface. And then in here, in the second part, it's we are passing in the data model. So we have movies, and these are some of the properties that we can apply the filter on. Then we have the match statement for the movie. And in cases where there is like a prefixed bucket value, like for the year range and revenue range, we also have the where condition. So these are some of the configurations that are getting passed alongside the data model. And what happens is that this search criteria is being looked at, and based on that, these configurations would be picked up, and then it's gonna come up with this final query, which is my Cypher query. And you might have noticed that basically the search criteria and the data model, they go hand in hand. They're super tightly coupled, and that's what makes this like a very sophisticated implementation. Another, so I also want to walk you through the phase two, which is the second part of this implementation. So we have the Cypher query in phase one that was generated here. So I'm going to scroll all the way down to my phase two Cypher query generation. So that's over here. So once we have the Cypher being generated from phase one, we are using this procedure called epoch.cypher.run that runs this Cypher query, and it passes in all the parameters. So there's search criteria, the search criteria map, and so on. And then all the results of the Cypher query are collected, which is our filtered result. And we are also doing additional like facet count on these movies, so we have a better understanding of how the data is distributed. So that facet count is done by this other procedure, which is epoch.column.frequencies as map. And I'm going to run this. And in here, you can see that on the UI, we had like 77 results based on all the filter conditions that I applied. And in here, you get like a more breakdown of those results. So like if we look at the runtime bucket, you would see that 38 of those results fall in this bucket between 2 and 3 hour runtime. And then if we look at revenue bucket, most of the movies fall under this revenue bucket, which is 500 million and 1 billion and so on. So I'm going to switch to my UI screen here. And yeah, so that's pretty much what I wanted to cover on the UI side. We have a GitHub repo, so if you want to go through the Cypher query step by step, you should be able to do that. And I'm going to hand it over to Eric, who's going to walk us through the areas that you need to watch out for uh, in this demo. Over to you, Eric.
Thanks, Snehal. Thanks for that great walkthrough. Yeah, so a couple things more on this issue with the 250. So we made this, big Cypher statement that's running these two phases, but in the same statement. And when we do that, what we're doing is we're returning both the facets and the results together. So there's no real result paging going on. We're not saying, hey, return the first 20 results, then the next 20, then the next 20, etc. So in our example, if you say were to go up to 1,000 or 2,000 to get higher facet counts, you're going to be returning also up to 2,000 results. And that extra data is just going to be not performant, right? So if you want to increase the facet count, what you probably would want to do is divide up the facet calculation part and then the results part, and maybe just run two different queries, one that just returns the results and one that returns the facet counts. So if you do that, then the facet counts could go way up. So that was one issue. The other thing is even if you do that, you're still possibly going to run into memory issues, because what happens is, in order to calculate the analytic piece where we're doing the facet counts, you have to pull all the results back into memory. And then once you've got to collect them up and then run apoc.collection.frequencies is what we were using. So if you use that same technique, then you want to be cognizant if you pull, say, 5,000 rows back into memory, or back to do the facet counts, that's going to be sitting in the memory. So you got to think about, do you have that much memory? If you've got plenty of memory, no problem. It's going to take a little longer, but also depending on your users, how many users are going through and clicking this stuff. So the more hits you're getting, the more memory is going to be consumed by each user's, taking up a bit of that memory. So just things to be aware of. From an implementation perspective as well, you'll see that the UI and the Cypher are very tightly coupled, especially in regards to bucket definitions. We went through and we defined the bucket definitions in the UI, and those we had to mirror the exact same bucket definitions in the Cypher statement so the counts could be done properly, and also so the keys could be correlated between the UI and the facets. You also saw that we put the model info inside the Cypher statement, and this is to help us auto-generate the site, the smaller Cypher, right? So the Cypher that gets generated based on the user selections, we put the model inside the Cypher statement, so then that could be dynamically generated Cypher. So those are things to just be aware of if you do this on your own. Let's go to the next slide, Snehal. We have the sample project out here. It's a public project under Neo4j faceted search. I think Snehal will have a few minutes here if you want to show them some of the code. And also the sample data set we use is linked there as well. There is a README file inside the GitHub project that you can go and take a look at. They'll help you run it and gives you a pointer to the dump file. So Snehal, if you want to just show the code and maybe show a few files, that'd be great.
Sure. So this is the link. I'm gonna just bring it up again. So this is the project repo where we have the UI and the API code. So I'm gonna open the source folder and just going to expand everything. So this is the home folder, and inside the home folder, we are calling this component movies. So I'm gonna open that up. And within the movies component, we have the facets and the results. So I'm gonna open the facets class because that's where most of the interesting things are. So here you will see that we have a preset bucket for movies, for years, and so on, because most of these values are numeric values. And on the user interface, you're going to see these values like really bad, not good. And based on whatever selection that gets made by the user, it's going to pass these low and high bounds into the to the API, which is something that the Cypher query understands. So we have some of these preset ranges for movies, year, revenue, and runtime. And then there's also a call that gets made. So I'm gonna scroll all the way down. And for some of the other properties where they are not numeric, for example, the genre, we are running another API call which gets all the results for that Cypher query. So get property values for this particular label genre, and that's getting invoked. And that's how you see all the properties on the facet side. And we are also doing some state management so that the variables are getting set correctly. So that's my facet count. And I'm going to go back to my results. So like if we look at this other class results, which is, it's basically parsing the Cypher query that I showed you, the two-phase Cypher query. And that query is taking in this variable, which is the search criteria that's getting set. Then we are taking the response and breaking that response into two parts. So the first part is the movies, what you saw on the right hand side, and then the second part is the facet count, which gives you the frequency of the distribution of the movies. And yeah, that's pretty much it. And you'll also see that we are limiting the results to 25. So I'm gonna go to my query now. So these are the so our app is powered just with, we just have two queries in the backend. The first query is to get all the property values for a particular label, which was getting invoked by the genre. And then the second query is the search with facets query. And it's a very big query, so it's taking in the search criteria, and then it has the data model which is embedded inside of that query. And then there is some lookup that's happening in order to generate a final query. So there's where snippet that gets appended from different places, and you should be able to run this query like step by step to see what's happening at every step and how the response is being like parsed. So at the very end, we have the cipher being returned at this stage, and following like line 162, we are running that cipher and calculating the facet count and so on. So I hope that is helpful if you end up navigating through this demo by yourself. And there's also a README file in here. In case you want to set this project up by yourself, you can just follow this and you should be able to run it with no issues. And then another thing I want to just quickly walk you through. So there's a sample data that's available at this link. So I'm going to open that. And I think there are other different dump versions that are available. So I think we picked up the recommendations 50, if I'm not wrong. But this is the dump that we used in order to create that movies database. So yeah, that I think that's all I wanted to cover. And thank you so much for attending our talk.
Thanks so much. Yeah, I try to answer the questions in the chat. So I think I got to all of them. I think there was 3. But yeah, we really appreciate you attending. Thanks so much. And yeah, I guess we leave now.
Good. Bye.